Vanakkam. Now we are going to solve problem 3.18 using nodal analysis from Fundamentals of Electric Circuits by Alexander and Sadiku's 5th edition. We are asked to determine the node voltages in the circuit. Okay. So this is first node, this is second node, and this is third node. So we have to find out the voltages as V1, V2, V3 respectively. This is the question asked. So let's mark the necessary things. Already it's marked. This is node 1, 2, 3 with the potentials V1, V2, V3 respectively. And this is our reference node. And here we mark the currents as I1 current flowing in this direction, I2 in this way, and I3, I4, I5. And we should notice that this V1 and V3 forms a super node because this 30-volt voltage source is not connected with the reference. Then it becomes a non-reference voltage source. So here these two forms the super node. Now we can apply KCL for this super node, that is 1 and 3. We know that KCL is sigma incoming current. Summation of the incoming currents is equal to summation of the leaving currents. So at this super node we are now going to write the KCL. Okay, so what are the incoming currents? This I1 is the incoming current for this first node, and this is leaving, and this I4 is entering into this V3, so incoming. This I5 is leaving. Okay, so incoming is I1 and this I4, and leaving are this I2 and this I5. Okay, so we can apply Ohm's law for this current I1. So you can write this as 0 potential minus this V1 potential divided by this 4 ohm resistance. So it is minus V1 divided by 4 ohms plus I4. I4 you can write this as V2 minus V3 divided by this 2 ohm resistance. So it is V2 minus V3 divided by 2, that is equal to I2 is V1 minus V2 divided by 2. Okay, and this I5 is V3 minus 0 potential divided by this 8. So V3 divided by 8. So if you take the common denominator here, this is 8. So here you can write this as minus 2V1 plus 4 into V2 minus V3, that is equal to, here also if you take common denominator as 8, it is 4 times V1 minus V2 plus V3. So these two can be cancelled out. So you can write this as minus 2V1 plus 4V2 minus 4V3, that is equal to 4V1 minus 4V2 plus V3. It is minus 2V1 minus 4V1. When you bring it to the side, minus plus 4V2, again plus 4V2 minus 4V3 minus V3, that is equal to 0. So on simplifying we get this as minus 6V1 plus 8V2 minus 5V3 equal to 0. This is our first equation. So now we move on to this second node. So for the second node we apply KCL, okay, at node 2. So what are the incoming currents? This is incoming, this 15 amps is incoming, this I4 is leaving, isn't it? So this is I2 plus 15 amps current, that is equal to this I4 current. So for I2 and I4 we can apply Ohm's law. So for I2 it is V1 minus V2 divided by 2 ohms. V1 minus V2 divided by 2 ohms resistance plus this 15, that is equal to I4 is V2 minus V3 divided by this 2. So V2 minus V3 divided by 2 ohm resistance. So when you take the common denominator here, it becomes V1 minus V2 plus 30, that is equal to V2 minus V3 by 2. So you can cancel out this. So it becomes V1 minus V2. This V2 can be brought over here. So V2 plus V3, that is equal to minus 30. So it is V1 minus 2V2 plus V3 is equal to minus 30. So we got the second equation. Again here, if you see, this is a super node. Already I have told you this first node and the third node or super node, isn't it? That means here we can apply this as V1 minus V3, that is equal to this minus 30 volts. So this can be taken as the third equation. So I can rewrite this as V1 is equal to minus 30 plus V3, right? So I am going to apply this in first equation. So we have all the three equations here. In this, the third equation can be rewritten as V1 is equal to V3 minus 30. Okay, just rewritten. And this third equation can be substituted in the second equation. Substitute this third in second equation. So that we get this as V1 can be written as V3 minus 30 minus 2V2 plus V3, that is equal to minus 30. 2V3 minus 2V2, that is equal to 0. That means V2 is equal to V3. Okay, this is equation number 4. So substitute this fourth equation in the first equation. So you can write this as minus 6V1 minus or plus 8 V3 minus 5 V3, that is equal to 0. So it is minus 6 V1 plus 3 V3, that is equal to 0. So this is equation number 5. And in this fifth equation, in place of this V1, you can substitute this, right? V1 is equal to V3 minus 30. So it is minus 6 into V3 minus 30 plus 3V3, that is equal to 0. So it is minus 6V3 minus 1 minus plus 180, that plus 3V3 equal to 0. So it is 3V3, that is equal to minus 180, or V3 is equal to 60 volt. So we got one answer. Now substitute this answer here. Okay, so now you can write this V1 is equal to the 60 minus 30, that is equal to 30 volt. Okay, and we know that this V2 and V3 are the same. That's why we can write this V2 is equal to 60 volt. So already we got this V1, right? V1 is 30 volt. So this is the answers we get. Thank you.